tree. Decision trees are a powerful and versatile machine learning algorithm that can be used for a variety of tasks. They are relatively easy to understand and interpret, and they can be trained quickly and efficiently. However, they can be prone to overfitting and sensitive to the order of the features in the training data. Decision trees are a powerful and versatile machine learning algorithm that can be used for a variety of tasks, including classification, regression, and anomaly detection. They are relatively easy to understand and interpret, and they can be trained quickly and efficiently. Hey everyone, and welcome to Learn to Profit. Today, we are going to be talking about machine learning algorithms decision trees. Decision trees are one of the most popular and effective machine learning algorithms, and they can be used for a variety of tasks, including classification, regression, and anomaly detection. What is a decision tree? A decision tree is a supervised learning algorithm that uses a tree-like structure to make predictions. The tree is built by starting at the root node and splitting the data into two or more branches based on a decision rule. This process is repeated recursively until each branch contains a pure set of data, or until a certain stopping criterion is met. How do decision trees work? To make a prediction, a decision tree starts at the root node and follows the decision rules down the tree until it reaches a leaf node. The leaf node then contains the prediction for the given data point. Example of a decision tree. Suppose we want to build a decision tree to predict whether or not a person will buy a product based on their age and income. Our decision tree will help to solve that. To make a prediction, we would start at the root node and follow the decision rules down the tree until we reach a leaf node. For example, if the person is over 18 and has an income over 50,000 and is male, then the prediction would be that they will buy the product. Advantages of decision trees. Decision trees have several advantages over other machine learning algorithms, including: they are easy to understand and interpret. They are relatively robust to noise and outliers in the data. They can be used for both classification and regression tasks. They can be trained quickly and efficiently. Disadvantages of decision trees. They can be prone to overfitting, which is when the model learns the training data too well and does not generalize well to new data. They can be sensitive to the order of the features in the training data. They can be computationally expensive to train for large datasets. How to train a decision tree model? To train a decision tree model, you need to provide it with a training dataset that contains both the features and the target variable. The features are the attributes of the data that you want to use to make predictions, and the target variable is the variable that you want to predict. The decision tree algorithm will then build a tree by recursively splitting the data into two or more branches based on the decision rules. The decision rules are selected to maximize the purity of the branches, which is a measure of how well the branches contain only data points from one class. Once the tree is built, it can be used to make predictions on new data points. To make a prediction, the algorithm starts at the root node of the tree and follows the decision rules down the tree until it reaches a leaf node. The leaf node then contains the prediction for the given data point. How to evaluate a decision tree model? One common approach is to use a held-out test dataset. This is a dataset that was not used to train the model, but is used to evaluate the model's performance on unseen data. To evaluate the model, you first make predictions on the test dataset using the model. You then compare the predictions to the actual values in the test dataset. The accuracy of the model is then calculated as the percentage of predictions that were correct. Another common approach to evaluating a decision tree model is to use a cross-validation technique. This involves dividing the training dataset into multiple folds and then training and evaluating the model on each fold. The overall performance of the model is then calculated as the average performance across all folds. How to prevent overfitting in decision trees? Overfitting is a problem that can occur when a machine learning model learns the training data too well and does not generalize well to new data. There are a number of ways to prevent overfitting in decision trees, including pruning. Pruning is a technique that involves removing parts of the tree that are not contributing to the model's performance. This can be done by removing branches that are less likely to be predictive, or by removing branches that are causing the model to overfit the training data. Regularization. Regularization is a technique that involves adding a penalty to the model for complexity. This encourages the model to learn simpler rules, which can help to prevent overfitting. Ensembling. Ensembling is a technique that involves combining the predictions of multiple models to create a more robust prediction. This can be done by averaging the predictions of the models, or by using a more sophisticated technique such as stacking or boosting. Now, get ready for the most exciting part of our journey, real-world applications. We'll explore how decision trees are used in various fields, from the medical world diagnosing diseases to the world of e-commerce making product recommendations. Decision trees can be used for a variety of real-world problems, including Fraud detection. Decision trees can be used to identify fraudulent transactions by learning the patterns of fraudulent activity. Medical diagnosis. Decision trees can be used to diagnose diseases by learning the relationships between symptoms and diseases. Risk assessment. Decision trees can be used to assess the risk of events such as loan defaults or customer churn. Credit scoring. Decision trees are used by banks and other financial institutions to score borrowers and determine their creditworthiness. Marketing automation. Decision trees can be used to automate marketing campaigns by targeting customers with the most relevant offers. Customer segmentation. Decision trees can be used to segment customers into different groups based on their characteristics. Recommendation systems. Decision trees can be used to recommend products or services to users based on their past behavior. Thanks for watching. If you enjoyed this video, please give it a like and subscribe to our channel for more videos on machine learning, artificial intelligence, and data science.